Welcome back, everybody.
Thank you, Ravel. Welcome back, everybody. So we got 3 problems for our warm-up. So let's get.
These cannot be right.
They can't
Seriously,
be right.
There's no way these are right. It's just like. What'd you say, bro?
Nothing.
Keep on yapping.
Hey, that's actually pretty close. That's pretty close. Okay.
I don't know what I'm doing.
Where'd you get the 1024?
I don't know. That's what I'm saying. Here, so, yeah, that distributes. That's already a 4. So then 5 to the 4th power.
Why is that already a 4?
Because it's second power. Then.
No, just the K's being raised to the second power. So
All
you're
right.
close. There's
All right.
there's good things happening there.
The fire's there.
Right. Just needs a little bit of a
The
need a
dog's
little
always
fan to
there.
the flames. All right. First thing I want to say, negative exponent for number 1. What do I do with that? What's that tell us to do?
Make it go down.
Make it go down to the denominator, right? The negative exponent moves it down to the denominator. So this is 1 over 10y to the positive third. Now, can I leave it like that? No. There is an exponent acting on 2 things. I need to do what with this third power? What am I going to tell you to do with that third power? Distribute it. Right, distribute it. So I'm going to distribute that in, and that's going to be 1 over 10 to the third y to the third. 10 to the third y to the third. Make sure that third power goes to the y as well, which you did not do there. Now, 10 to the third, reduce it out. Well, any power of 10 raised to a certain, or any power of 10 is just the 1 with that many zeros after it. So 10 to the third is just a 1 with 3 zeros after it, so 1,000. Y to the third. Are you allowed to give decimals? No. No decimals. Okay, questions so far? Questions so far? All right, let's take a look at the next one here. Now, there's no negative exponents acting here. So I don't need to worry about any of that, but I do need to bring in the 5, right? And that 5 does the exact same thing to my quotient as it does to my product that I had at number 1. That 5 basically just gets distributed everywhere. You want to know a key, a place where a lot of people make their mistakes? You forget to distribute it to the number 2. That's where a lot of people forget. So we have like 1 to the 5th, 2 to the 5th, and that's where I say a lot of people are going to make their mistakes. You're going to forget that. Now, what's my power on K? What's going to be my power on K? K to the what?
7.
Ooh, don't add. What do I do with that?
No, right. I hate it.
Got it? To the 10th. To the 10th. You were close. You were so far off. You added instead of multiplying. That's not too bad. Okay. Now, where is that coming from? That's power to a power, right? That's a to the m to the nth is a to the m times n, right? K squared to the 5th is k to the 10th. Now, I just have to reduce out the numbers. Like 1 to the 5th is just 1. 2 to the 5th. Okay, 2 to the 5th. 2 to the 3rd is 8. 2 to the 4th is 16. 32 is... Excuse me. 32 k to the 10th. There's my answer. Questions there? Okay, let's take a look at our last one there, number 3. 6c divided by 7, all raised to the negative second power. All right, somebody tell me, what does that negative tell you to do on the fraction? Flip it, right, take the reciprocal. 6c goes down to the bottom, 7 goes to the top. And then that becomes a positive 2 power. A negative exponent on a fraction tells you to flip the fraction and then make that exponent positive. Let's bring in that 2. That's going to be 7 squared over 6 squared c squared. Right? So I bring in that squared power, 7 squared over 6 squared c squared. Now, 7 squared turns into 49. C squared is 36. Or sorry, 6 squared is 36. C squared stays. Questions about that? I'm telling you right now, folks, those of you who are not doing your homework, or those of you who are just like copying your answers off somewhere, it's going to be an issue when you get to your quiz. You will not understand this stuff if you don't practice this stuff. Sincerely practice. Okay. All right, let's go through some problems on the homework. We got 10 to 28 even, 34 to 40 even. Sadie, give me one. 34. Oh, there weren't any scientific notation problems on the homework last night. I was wrong. I thought there were going to be. Good thing. It's okay that we didn't get to it. I got to go. We'll do that today. So number 34 here. So very similar to one of my warm-up problems, right? I'm just going to take this 1 over 4x to the positive fourth power so far. Yeah, push it to the denominator. That's the negative exponent. And then distribute that fourth power in. So that's going to be 1 over 4 to the fourth x to the fourth. But then 4 to the fourth, got to evaluate that. 4 to the fourth is 256. X to the fourth. Make sense? What else do we need to see? Yeah, Gabby? 26. 26. There it is. Okay, let me move the other one around it. Get this out of the way too. All right, now this one is a little weird because normally we're expecting bases that aren't numbers, but this one is a number. What is the base here? The base is -7. And it's weirdly enough not set up in parentheses like the other one. Isn't that -7 to the first power? If there's no power written, isn't it to the first power? All right, so we have -7 to the first times -7 to the -4th. Okay, what is that? Now, the base doesn't change. Stays -7. Just like all of these. The base never changed away from A for any of those. The only time it changes was A to the 0, right? Now, when I am multiplying with my bases, what does that tell me to do with my exponents? When I'm multiplying with my bases, what is that telling me to do with my exponents? Somebody tell me. When I'm multiplying with my bases, what does it tell me to do with my exponents? Add them. So 1 plus -4 is -3. So which is, and that should be in parentheses, 1 over -7 to the positive 3. And let's evaluate that. -7 to the third power is -343. And there's mine. Questions about that? Give me another one to go over. Isabel? Number 16. All right. We always get a little worried when we see problems like this. I don't know why, but students tend to freak out a little bit when you see problems like this because there's a lot going on, right? It's all these ones, 13 all the way through, right? There's a lot going on, a lot of different pieces and parts. But if you take it piece by piece, it's really not so bad. For example, is P happy where it is? No. Goes down. Is 7 happy where it is? Nope. Move it up. Yeah, Q isn't either, right? Nobody's happy here.
There's a lot of unhappy marriages.
I know. So now we say 49 Q to the 9th over P to the 8th. Make sense? Yeah, as long as you don't get overwhelmed. Like a lot of people look at the problem, get overwhelmed, and just shut down. Don't do that. Look at it piece by piece, and it's not so bad. You can't just shut down. If you shut down, you're never going to learn anything. You got to push through and say, okay, what do I know? What are the little pieces that I know to do here? All right, let's go over one more. Somebody give me one more to go over. Yeah, Melody? 36. Okay. So raise it to the second power, bring this in. This is negative t to the second over 3 to the second. Now, when you square a negative, what happens? Negative times a negative is a positive. So the only thing that happens at the top is just turning it into positive t squared over 9. Questions? Is there anything else anybody would like? Yeah, go ahead, Sadie.
Oh, I just have a question about that.
Yeah.
Where did we get the positive t?
Because the negative was squared, right? So like if I wanted to write it out, the top was this, right? Doesn't that say this? So negative times a negative is a. Does that make sense? Is there anything else on the homework? Again, you got to ask questions when you have them. Okay? Got to ask questions when you have them. Can we please take out our guided notes from yesterday? I would like to hit the problems that we did not go over yesterday. Yeah. Looks like that. All right, so if I remember correctly, we did not do C or example 4, correct? So let's do those. Okay. So we're on the back, example 3C. And then we'll do example 4 as well. All right. So there are 2 different sets of parentheses here, right? 2 different sets of parentheses. So what I'm going to do is I'm going to take them one at a time. Okay. What is that telling me to do on 2/3? Flip the fraction. It's telling me to make that 3 over 2 raised to the positive second power. Likewise, what is this negative telling me to do? Flip the fraction. So that's going to be 2n over 6m raised to the third power. Okay, what do I do with this second power? And coincidentally enough, also with the third power.
This announcement is to let those members from group 1 to take the Accuplacer, please go to the hotspot now. That's group 1 for the Accuplacer, please go to the hotspot now.
What is this? What do I do with the power of 2 and the power of 3 here? Zach? What's the thing?
Do you want to say it? Distribute it.
Distribute it. Distribute it. Good. Yeah, you distribute it. So I am going to distribute the 2 in here to make that a 3 squared over 2 squared. Now, I totally understand. If you would like to go straight to the numbers at this point, I'm totally good with that. But you're going to see me writing it out like that just so you can see it. What do I mean by that? If you want to go to 9/4 in this next step, do it. That's totally fine. You can do the same thing here with this third power. Everybody gets raised to the third power. So 2 to the third, n to the third, 6 to the third, m to the third. Now, could I make, actually, you know what, it might be better if I don't. Ooh, watch this. This is going to be good. Could I make those all numbers and multiply them? I mean, all except for the m and the n, right? Yeah, but watch what I can do here. Because multiplication is just straight across on top and straight across on bottom. This would turn into 2 to the third, 3 squared, n to the third, right? Look at all the pieces on the top. 2 to the third, 3 to the second, n to the third. All right. On the bottom, I would have 2 squared, 6 to the third, m to the third. Do you see what I can do right here? What do I do with the exponents on that base of 2? What do I do with those exponents? Somebody tell me. What's that? Subtract them, yeah. So this would be like saying 2 to the first, or just 2, times, now we can evaluate it, 3 squared is 9, n to the third, over 6 to the third. Now I don't know that offhand. 6 to the third, that's a big number. 216. M to the third. Okay, so 18 n to the third over 216 m to the third. Well, I guess that didn't, I mean, it reduced it down a little bit. We still have to reduce this fraction. I have to reduce this fraction 18 over 216. Everybody see that fraction that we have to reduce? If you have a number, if you have a constant sitting out front in both numerator and denominator, you've got to reduce it down. Okay, so let's find numbers that divide 18 and 216 evenly. Do you have a question?
Yeah.
What's up?
Did we cancel out the 2 to the third and 2 to the second?
Yeah, it became 2 to the first. Because we subtracted 3 minus 2 is 1.
Oh.
Yeah. Now, let's try to reduce down to 18 over 216. What does 18 divide by nicely? 6. 9. Okay. Let's see if 216 also divides by 9. Sweet. Maybe there's something bigger. Is there something bigger 18 divides by? Bigger. 18. I wonder if 216... Hey, 216 divides by 18. Lucky for us. So it's 12. So that means we have n to the third over 12 m to the third. There we go. Yeah. Yeah.
Okay, I feel like you doing it with all the powers and stuff just confused me more.
Yeah, I know. Honestly, it might have been better just to go straight to the numbers.
I think so.
I thought it was going to reduce it easier, but it didn't.
Because, so, you see that right there?
Yeah. And then you just take 864 divided by 81. Yeah. Because 861 divided by 864, excuse me, divided by 81. Oh, I guess that's not. Well, it was close.
Wait a minute. Okay, so, is I right or wrong?
You were close. Put it that way. All right, let's do the scientific notation problem.
I can do this. Hold on.
Okay, so let's talk about scientific notation. You know, you've studied scientific notation before, right? In science classes. It's not too bad. But, you know, so what is scientific notation? Well, in a nutshell, it's just basically a way to represent really big numbers in a shorter way. Or a way to represent really small numbers in a shorter way. You know? Because, like, scientists from long ago, they didn't like writing out, 146 million. Right? They were like, I'm too lazy for that. So let's say 1.46 times 10 to the, well, what would that be? 1.46. How many times you move? 8.
She knows.
3, 6, 2 more, 8. Right? You go to the 1 unit before, right? 1.46 times 10 to the 8. So scientists said, well, instead of writing out that many zeros, because before the days of computers and stuff like that, wasn't as easy to just type it in. You had to hand write all the zeros in, and that could get tricky. What's that? Right. So you just have, okay, I know there's eight decimal places after the 1. Yeah, you should go 8 to the right, and there's your number. You could also do this with a really small number, right? Like 0.000072. That would be 7.2 times 10 to the what?
6.
Be careful. Negative 1, 2, 3, 4, 5, 6. Remember, a negative exponent is representing a really small number, just like what we learned in here, right? Are negative exponents negative numbers? No. Negative exponents are fractions, are small numbers, just like in scientific notation. All right, now that being said, let's take a look at this problem here. A jellyfish emits about 1.25 times 10 to the 8th, so a big number of particles of light, or photons, if you will, in a really small amount of time. They emit a lot of light in a small amount of time. How many photons does the jellyfish emit each second? Write your answer in scientific notation in standard form. Now, when I say in standard form, that's basically just saying, okay, write it out. Write out the big number. Okay, so we have 1.25 times 10 to the 8th particles, photons. And I know it emits that in a really small amount of time. I basically want to find a unit rate here. So all I have to do is divide it by that 6.25 times 10 to the negative 4. You may be thinking, how in the heck does this relate to exponents? Well, powers of 10. And watch this. Isn't this x multiplication? Right? Isn't that just a times symbol? Times 10 to that? So what I'm going to do is I'm going to divide this separately from this. Okay, what is 1.25 divided by 6.25? Somebody do that for me. 1.25 divided by 6.25. What is it? 0.2. Okay, what is 10 to the 8th divided by 10 to the negative 4? When I'm dividing powers, don't I have the same base? When I'm dividing, what do? Subtract. So what is 8 minus negative 4? What is 8 minus negative 4? 12. Okay, is that in scientific notation? No, be careful. That is not scientific. Looks a lot like scientific notation, but it's not true scientific notation. I have to take this decimal and put it right over there. Now, this is, a major sticking point. People always forget. What do I do with the power? It goes down. It goes down. If you ever are worried about it or don't know what to do about that, well, just put it back into standard form and then throw it back into scientific notation. What do I mean by that? If you had 0.2 times 10 to the 12th, well, that would mean I need to move that decimal place 12 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is this number? Well, comma here, comma here, comma here. Okay, so this is millions. This would be 200 billion, right? 200 billion. Right? Because this would be like 100,000s, millions, billions. 200 billion, right? Okay, well, putting that back into sign notation, how many zeros do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 2 times 10 to the 11. So written as standard form and then as scientific notation. Rule of thumb there is if you want to change the number, if you're making this number smaller, you got to increase the exponent. If you're making the number bigger, we went from 0.2 to 2, you decrease that exponent. All right, that's it for the guided note.